Hello friends, in the last lecture we had a discussion on stuffing box assembly where I have explained most of the critical parts where student will get confused where to start the drawing and where to end the drawing. And I have also explained you about how to place the dimensions, how to place the component numbers. Then later at the end how to draw in the bottom right corner of your drawing sheet, how to draw the table given in your question. In the same way, I'll try to simplify and try to draw in a faster way. We today discuss about screw jack. Jack itself indicates that it is used to lift a body. For example, jack that we use in your car. Okay, for example, something goes wrong, we'll try to lift the car with the help of a jack. Okay, jack contains many components. You could see from 1 to 7. Okay, given in the table, name of the part is given, material given, quantity also given. So all the parts are placed here with all the standard specifications. Okay, we have to assemble them all to get the proper component in their working conditions or working positions. Okay, we need to place all the parts in its working positions. For example, have a look at part number 1. As I said, drawing part number 1 initially is more important, then comes the smaller parts assembled with the part number 1 can be seen here, which is maintaining 185 dimensions, 185, 100, 140, 70, 50 major dimensions. Similarly, have a look at part number 2. This is the part number 2 where all the dimensions were given and the top view is also given. Okay, for part number 1 no top view is given. Means when top view is not given means it indicates that the information which is required to draw the sketch is already given in front view. So top view is no need of giving a top view in the question. Similarly, have a look at part number 4. Front view, all the dimensions are given, few dimensions are missing. Those dimensions are given in the top view of front view. Okay. So similarly, part number 7, no side view is given, not required because most of the dimensions required are given in the front view itself. Similarly, these two parts also. There is a washer, there is a screw given. Okay, we need to assemble them all. Have a look at part number 3. This is also given where you have threading. Here double line indicates that there is a threading from here to this point where 250 minus these dimensions will give you this length. Okay, now here it is maintaining a diameter of 38 by 7. The same dimensions maintained by some other component that we need to find. That is more important. Now have a look at this part number 1, which is having a depth of 40. There is internal diameter of 50. How much? Internal diameter of 50. So do you find any diameter of 50 other than part number 1 anywhere in the sketches? Here you could see there is a diameter of 50 above and below. So this 50, there is a chance or scope that can sit in part number 1 till a depth of this much. What is this depth? 45 minus 10, 45 minus 20. So 20 is the depth. So 20 depth will sit or will go inside the part number 1. Here have a look. So this will sit inside part number 1. Then what is the minimum diameter of part number 2? Once it got inserted, there is one more minimum diameter for part number 2. What is that? Which is 38 by 7, which you could see top view of part number 2. Okay, top view of part number 2. The diameter of 38 by 7. Now this 38 by 7 is matching with this 38 by 7. So it indicates that there is a hole in part number 2 which is already inserted in part number 1. So in that part number 2 I can insert part number 3 up to this length can be calculated out of 240 minus these dimensions. Okay, it will go and sit inside completely. Okay, so this bottom horizontal will come and match with this top horizontal of part number 2. Try to understand, this bottom horizontal will match with top horizontal of part number 2. Okay, then on the top of part number 3, part number 4 will come and sit because the dimensions here are diameter 22 matching with diameter 22. Here diameter 22 is a shaft, here diameter 22 is a hole. So obviously it will come and sit on the top. So what is the width maintaining? It is maintaining a width of 12 mm. Here it is maintaining a width of 13 mm. So there is 1 mm left above the part number 4 where on that 1 mm you can place this washer, then again a screw to fit these two components. Okay, and to fasten and unfasten, to make the component move up and down, we use a Tommy bar, which is part number 7, which is having 275 length. Okay, 100 knurling point. Knurling nothing but to hold the component. Again, this 6 to 2 is the length going to insert in part number. Okay, 12 is the dimension, which is again a diameter of 12 by 62, which is going to sit in this particular part number 3. Okay, now the assembly, I'll make it so simple. I'll try to simplify this particular drawing. Now we see the assembly of a screw jack. Okay, now as I said initially, we'll try to draw the part number 1 of screw jack. Okay, I'll start from the base, I'll go till the top. Okay, then now I'll take one horizontal. I'll try to draw the base first. Now out and out dimensions are 140. Now have a look at the question. Part number 1 bottom dimensions are 140 and 100. So 140 by 2, I'll make it into 2 halves. Okay, which is maintaining a thickness of 20. From here 20, I'll make a mark 20. Okay, then again from here I'll try to measure a distance of 185 from here to this point somewhere here. So where my component is going to end up, I'll make a mark in the center 185. Okay, from here to this point it is going to be 185, this distance 185. So part number 1 going to sit in between these two lines. Okay, wherever I got this 185, I'll try to divide this into 2 segments. 70, outer dimension 70, so 35 on both sides. I'll try to close the line, draw a line, and there is a depth of 40. Okay, there is internal diameter of 66. Internal diameter of 66 given in the question, and here again a diameter of 100 given. Okay, already is maintaining 140, so here it is 100. So what I try to do is, based on this line 20 height, I'll try to draw a length of, like for example 100. So from the center 50, I'll close the line. Okay, fine. So from the center to this point it is going to be 50. From the center to this point it is going to be 50. So overall it is going to be 100. Outer it is going to be 140. Okay, here I'll try to measure a distance of 66, which is again given in the question. Okay, so from here 66 already is maintaining 72, 70, out and out 70 minus 66 is 4 mm. So from here I'll make a mark of on both sides, 2 on both sides. Okay, then what I try to do is I'll try to join this point to 100 mm diameter from here to this point with the help of a drafter scale. Okay, similarly this one. Okay, the shape is going to be something like this. Okay, now you can join this line also. If it is not a sectional view, you can join this line also. If it is a sectional view, don't join the complete line. If it is a half sectional view, only draw till this point. Okay, if there is no sectioning, you can continue the line, not a problem. Okay, internally there is a hole of diameter 50, which is given in the question again. 50 means from here 25 mm. Now draw the 25 down. Okay, then again from here wherever you got a slant edge, draw line till it go meet 100 mm. So make a mark of 100 on the bottom horizontal and draw this line. Means there is a groove, 100 dia groove in the bottom face of part number 1. Bottom face of part number 1. Okay, now this is maintaining a width of 20. Okay, now this width is given as 3 mm width, and here this diameter is given as 140, and this diameter is given as 100. This diameter is 140, and there is a width of 10 mm to be maintained. Okay, this is about part number 1, where I can place one more part over. Now as I said in the beginning, take part number 2, which is maintaining an internal diameter of 50 dia. So the part number 2 come and sit on part number 1. So the bottom depth of 45 minus 10, 45 minus 20, so it is going to be 25. So 25 going to insert, already is maintaining a depth of 40, so 20 going to be something 25, maybe up to here. Okay, make it hidden because it got inserted. Then again there is a leading edge of 90 from the center 45, already it is maintaining 70, so 45 means it will obviously come out, this will also come out. Okay, then again there is a height of 10 mm, diameter of 50, this is matching with this. So join till this point with your scale Then again gap of 10 mm, draw one horizontal followed by a inclination line joining both. Okay, clear? Then again what you try to do, there is one more hole, minimum hole of diameter 38 by 7. When I have explained you initially, there is a diameter of 38 by 7 minimum from top to bottom, so that is maintained here. So that you need to show with a hidden line. Okay, one side or two sides, not a problem. Now try to take part number 3, insert from the top. Okay, try to make the bottom horizontal. So when you do that, what happens, bottom horizontal will come sit here, then what happens, rest of the component will come on the top of part number 2. So here you could see, now it is maintained at a gap of 10 by 45 degrees above and below, and overall width of 83, overall width of 83 and height of 83, overall width of 65. So from the center measure 65 by 2. Okay, 32.5 on both sides. From here, maybe this point, I'll try to draw the horizontal. Okay, so maintaining gap of 10 mm, draw one more horizontal. From here, align your drafter to 45 degrees, draw 45 degrees line until it go and meet with the horizontal above. 45 degrees line, something like this. Okay, now this box is, part number 3 box is maintaining a height of almost 83 minus 13 mm. 83 minus 13 mm. You need to subtract the top shaft. Okay, 83 minus 13, 70. So from here, draw that 70 mm. Close the box. Okay, again 45 degrees line up to 10 mm width. Again 45 degrees line up to 10 mm. Okay, the part is going to be something like this. Rest of the part will insert into part number 1. So when it inserts, what happens, it becomes invisible. So make it invisible with a dashed line, something like this. Okay, now you need to draw double line because it is having threads on the shaft. Okay, then something like this. Okay, whatever the arrangement given in the question, accordingly try to maintain that length, maintain that shape, and make the lines dashed lines because it is inserted completely inside. Okay, if it is a half sectional view, darken these lines and let the hidden lines be hidden only. Okay, on the top of this there is a sectional view given. On the top of this there is section given, means some material got removed to show the internal intricate shape. Okay, then there is a shaft over which is of dimensions 13 by 12. Okay, maintaining a height of 13 and diameter of 12, means 6. So close this. Okay, which is again having some internal hole. Okay, shaft is having an internal hole. So here you could see internal hole. Okay, manually you can make it with the help of small scale. Fine, this is the arrangement. Part number 1, part number 2, part number 3. Most of the things were set. Now what about part number 4? Take part number 4, this 13 mm matching with part number 4, 12 mm. So there will be a clearance here. I'll take part number 4, which is maintaining bottom width of 45 and a hole of 22 dia and overall height of 42. Okay, from here it is maintaining a height of 42. Okay, and outer we don't know, outer diameter is not given. You can have a look at part number 4 top view. It is given it as 65 from the center. Okay, overall it is, the diameter is going to be 65 by 2 will give you complete dimensions. Okay, 32.5. From here make a mark of 32.5 on both sides. Okay, then again bottom, from here it is going to be 45, out and out 45 means 22.5, somewhere here and here. Okay, this is 45, from here to here it is going to be 65. These dimensions 65 can be seen in top view of part number 4, 45 can be seen in front view of part number 4. Join these two lines, 1, 2. Okay, then it is maintaining a thickness of how much? It is given in the question, 6 mm. From here make a mark of 6, draw one more line, 6, one more line. Okay, join the line with the something like this, join it. Okay, now continue the line, there will be a curve, close it. Okay, hollow section inside which is completely open, so it is maintaining a thickness which is a circular object. Fine, from the top what you could see is, you can place the washer which is part number 5. Okay, you can place the washer, so just indicate a double line, just indicate a double line enough. From the top try to place the screw, which is part number 6. Okay, once the screw is placed, it will look something like this. Simply draw inclination, close it. This indicates that there is a screw. Okay, the complete arrangement is fixed something like this. Okay, try to understand. Now here it is maintaining a thickness of 6 mm. Okay, and there is a height. What is the height maintained by part number 4? Overall height going to be 42. Okay, then this out and out diameter going to be 65. Okay, and this height from this point till this point, the height going to be 185. Okay, this outer dia going to be how much? Given 70. Roughly I'm placing all the dimensions, but you have to give an arrowhead. Okay, and there is a depth of 40 mm. There is a thickness of 20 mm. Diameter is already given. Okay, and never place the dimension internally, try to place it out mostly. Okay, and here there is a dimension of how much? 38 by 7, sorry, diameter 38 by 7, which is matching with both. And here there is a dimension of 83 from top to bottom. Here from here to here it is going to be 83. Okay, and here this height is 13 mm, diameter of 12 mm. Fine. Now this is maintaining what? 10 by 45 degrees. 1 2 3 4 all are maintaining 10 by 45 degrees. Okay, there is a knurling. How to place the knurling I'll show you. And there is a hole somewhere here. There is a hole of diameter 12 mm. Okay, where Tommy bar will sit, something like this, which is part number 7. Okay, the component is rotated, Tommy bar can be shown from this side also. Okay, so I'll try to remove this hole. I'll try to turn the component. I'll try to place the Tommy bar. So this 62 having a diameter of 12, maintaining a length of 62. From here I'll try to maintain that 62. After that 62, it is going to be inclined. Okay, then there is a diameter of 20 maintained. 20. Okay, then show the cut section, because we can't draw the complete length of 275. That is the reason we are showing a cut section. You can draw any convenient length. This length could be any convenient length according to your drawing sheet, but you have to show the number as 275 only. Close it. Okay, for holding purpose, try to place the knurling that we have learned in our first topic, diamond knurling, for holding purpose, because we hold it and we turn it, hold it and turn it, so it will go up and down accordingly. Okay, same thing here also, it is knurled. Knurling is given on this part also. Okay, this is how we'll show the assembly. When I view from the top, what I could see a diameter of 65, 70, then again this dimension, then again the overall dimension of 140. So when I view from the top, what I can draw is, I can take a distance away from the top view, a horizontal, then I'll try to draw the component. Now here drawing 140 is not sufficient, space is not sufficient. What I try to do is, I'll try to make a mark of 140 from here to here, this point also. Then I'll try to draw simply a semicircle, drawing semicircle. This is also okay. In your external or internal, if the space is not available, you can manage with a semicircle. Okay, then along with the semicircle, I could see diameter of 65 and many others. Okay, there is a screw. Okay, then again there is what? Tommy bar. So that has to match with this Tommy bar length. Then again knurling has to be shown. Again the cut section has to be shown. Okay, simply draw these dimensions and show the dimension, the diameter of 140. Okay, here there is a diameter of how much? 65. Again there is a minimum diameter of your screw, which is 24. Okay, this is 24. So this is how we'll draw an assembly of a screw jack. Okay, and also try to place the numbers. This is part number 1, this is part number 2, this is part number 7, this is what? Part number. Draw the circle with the help of compass or a stencil. Again draw circle or else any other compass, and you can draw the leader line with the help of a drafter. It will maintain some angle, and this has to be drawn horizontally. Okay, similarly, is there anything missing? Now here this point, this is again part number 4. Okay, if you could align all the circles, it will look even better. Okay, try to draw all the dimensions properly. Show the dimensions with the dimension line only. Dimension line has to be something like this. Draw a line, drag above and below to get the arrow, above and below to get the arrow. Place your diameter or dimension, whatever. This is very much important. Below this bottom right corner, try to place the box whatever given in your question with serial number, name of the component, material, quantity. Draw the table, similar table given in the question. Then again units, saying that all the dimensions are in millimeters. Okay, if you reduce the scale, write the scale also. Scale is equal to 1:2 or 1:1. If it is 1:1, nothing but whatever the dimensions given in the question, accordingly I have drawn. That indicates 1:1. If you taken same dimension, no need to represent. If you reduce the dimension, then only you need to represent. Here I have not taken any reduced dimensions. Okay, if the space is not available, sufficient space is not available for you, what you could do is you can directly change it to 1:2. If you change to 1:2 also, original dimensions has to be placed in the drawing. You are not supposed to place the dimensions after division. Okay, this is about a screw jack where you need to draw with utmost neatness. Use 2H pencil initially to draw complete sketch. 2H. Then once it is done completely, whichever need to be darkened has to be darkened with HB pencil. This is very much important. That is one. One more point I would like to add is, now the question may be something like this. Draw the front view, top view of a screw jack. If that the question is something like that, you have to draw this way, or else draw the sectional view. Half sectional view of a screw jack means half section has to be hatched completely. One side has to be hatched, whether it is right or left. Okay, means one half will going to be removed. For example, have a look at top view. If it is a half sectional view, I'll try to remove this portion complete out of complete circle. I'll try to remove this quarter. When you view from the front, what happens? The half will going to be hatched. Whichever got section need to get hatched, something like this. Okay, other thing will remain same. If the complete thing is section from one side to the other, for example section something like this, complete thing is section, then what happens? Other side also you need to hatch complete thing from top to bottom. Here also, here I am drawing only half sectional view. Try to make a note sectional view indication. If you draw this much, this is enough, which will carry 45 marks in your external. Okay, try to catch up with the upcoming videos. Thank you for now.